All right, so multi-step simplification of rational
Ms.
exponent.
Chasen to dance, please.
Kidding.
Ms. Chasen to dance up in the 8th grade.
Multi-step simplification of rational exponent expressions. This looks pretty challenging, right, when you take a quick look at it. The whole key here is making sure that you get this, that you have the same type of term on in the numerator and the denominator of a fraction. Remember that in this particular, read the question carefully. In this question, we're being asked for our answer in the form p to the n, where p is a single term and n is a constant. So n has to be any number. As we can see, if n is a rational number, which means that it could be a fraction, then simplify it to its lowest terms, right? This tells us that it does not want it in radical form. It does want it in exponential form, so we are going to have to make sure that we end up with the same kind of form as we have in the denominator. Okay, so let's start, I think, by converting everything to what we have in the denominator, because that's what we're being asked for at the end of the day. So we need to make sure that getting started in that particular way is going to help. Okay, the first thing here is converting these two numerator terms to exponential form. And we know that if we have a radical, okay, with an exponent, where a base on the inside, and we have, say, an a to the x, and it's the white root of something, that is the same as a to the x over y. Okay, we know that that's something we learned from our exponent rules. Okay, so we can actually use that rule to convert our numerators. Okay, so the seventh root of 2k to the third power all to the fifth power would, of course, let's just take 2k to the third power as our base. So we're going to go with 2k to the third power, okay, and that is going to be, well, if you look at what we've got, our y, which is the denominator of our fraction, our y is going to be 7, that's the denominator of our fraction, and our numerator is going to be 5, okay? So that's what we've got going on the 2k term. That is, of course, multiplied times. We do the same kind of thing with the 17k squared there as well. We're going to go 17k squared. That's inside our parentheses. And our fractional exponent, of course, is also 5/7. Okay, so if we've got 5/7 going on there, 5/7 going on there, that is interesting because that is something we can bring together. Remember, same exponent. If you've got a to the x times b to the x, that's just equal to a times b to the x, right? Remember that from your exponent rule. So we're going to apply that in a second, but let's just bring our denominator down to begin with, right? 34k to the fifth power, and that is to the 2/7 power. Okay, so let's bring the numerator together. So now we're going to deal with this numerator, and we can actually apply this this exponent property rule to it. So let's deal with that. We now have we can multiply the 2k to the third times the 17k to the second, and that's going to go inside that's going to go as our numerator, okay, in our parentheses. Okay, so inside the parentheses here, we've got 2 times 17, of course, is 34. This is looking promising. Okay, we've got k to the third power times k to the second power, and again, remember your exponent rule. If you've got a to the, say, you've got the same basis, so a to the nth power times a to the mth power, right? That's going to be equal to a to the n plus m. So we can just add those two exponents together, and that becomes k to the fifth power. All right, this is looking really promising now because we can see that it looks pretty similar to our denominator, and of course we've got to raise that to the 5/7 power. Okay, we're going to just put that right over our denominator that we started with, and then the magic starts to happen. Okay, so remember now, with the same kind of rule that we had from our exponent rules, and it's kind of like the inverse of this multiplication rule, is if we've got a division problem with the same base, let's say a over b, and we've got two different exponents. We're going to use n and m as, again. That is just, sorry, that should be a over a to the n over a to the m. That's equal to a to the n minus m, right? So it's the inverse of the multiplication one. And we notice here that we have the same basis. So we can use that. So we're going to use that, and we're just going to go with straight with 34k to the 5th power. We don't need to do anything else with it. And we have 5/7 minus 2/7. Okay? These, of course, should be sevenths. There we go. 5/7 minus 2/7 is, of course, 3/7. So we end up with 34k to the 5th power to the 3/7 power. And that's where we leave it. Remember that Khan Academy is asking us for the form p to the nth power, right? And that's exactly what we have. 34k to the 5th power is our p, and 3/7 is our nth power. So just because it looks complicated at the very end doesn't mean that you haven't reached the right solution. Okay? Let me know if you've got any questions.